So we have these two objects, a car at 70 miles an hour and a train at 50 miles per hour. They're moving in the same direction and the train is 800 meters long. We want to see how long it takes for the car to pass the train. So we have to put that in the context of math to be able to solve it. The equation that we have is just x minus x naught equal to vt. But this talks about one object, right? It has initial position x naught, final position x, its speed is v, and the time between those positions is t. But here we have two objects. So we need to use different notations for different objects. We can call the train number 1 and the car number 2, if you wish. Then draw a x-axis, and then we start the time when the car reaches the end of the train, and then we want to find the time when the car reaches the front of the train. Right? So let's say the train is this long, and then the car is here right now, and time starts there. Let's call the car number 1 and the train object number 2, or vice versa. Okay, for the car, we want to see how long it takes for the car to reach the front of the train, right? So it's like one object is the car, the other object is the front of the train. So basically, let me put that in here. The second object is the front of the train. But the time starts when the object is at the end of the train, right? So for the object number 1, we have initial position equal to what? We put this equal to x equal to 0 here. So initial position of the car is what? Is 0, right? And the initial position of 2, now we call it x1 naught, because we have this one is number 1. Everything about the car has index 1. Everything about the train has index number 2. So x2 naught is like the length L, let's say, in general. And L is 800 meters, right? After time t, this front of the train goes somewhere, and the front of the car goes to the same place. But we have a formula for each one. We say x1 minus x1 naught equal to v1, the speed of the car, times t. Right? And then for the front of the train, we say x2 minus x2 naught equal to v2 times t. Right? And we're looking for t when the front of the train and the car are at the same position. x1 is equal to x2. x1 is the position of the car. x2 is the position of the front of the train, right? We want to find time when these two are equal. So put them equal. So x1 is x1 is x1 naught plus v1t, and x2 is x2 naught plus v2t. And then if you put these together, you put the other sides together. So it becomes x1 naught, and x1 naught is 0. So let me just put 0 here. And this. So it becomes v1 t is equal to x2 0, which is L, plus v2 t, right? And now solve for t. How do you solve for t? You have to bring this over. Comes v1 t minus v2 t equal to L. And factor t, v1 minus v2 times t equal to L. So t is equal to L divided by v1 minus v2. See, that justifies what you did. You considered the relative speed of those, the velocity of the car minus the velocity of the train, right? So the difference was 20 miles an hour. The length is half a mile, divided by 20 miles an hour, get 1/40th of an hour, right? So that's half a mile divided by 70 miles per hour minus 50 miles per hour. So T is half a mile divided by 20 miles per hour. That will be 1/40th of an hour, right? 1/40th of an hour. 1/40th of an hour is 1.5 minutes, which is 90 seconds. You can convert to seconds, 90 seconds. Of course, it's not that complicated. Sometimes when you think about it, it seems a little bit complicated, but if you put it in math, it becomes a very simple problem, right? But you need to be able to set things in mathematics. After that, it will be easy. So that's the main problem in physics, how to set it into math. After that, it's easy. It becomes a simple math problem, right? And in order to do that, look at the context. We have this formula. What does it say? It says between initial position and final position, the difference of the position is equal to v times t. But the position has only quantitative meaning if you have an axis and start from somewhere, go to somewhere. So you have to do that. Always pick a coordinate axis. All of these formulas are talking about an x-axis and a time between them, and initial velocity and final velocity is talking about the parameters between initial situation and final situation. So you should be always clear about what is your coordinate axis, what is your object, what is your initial situation for that object, what is your final situation. If you know about that, then it becomes very, very easy. In fact, if you do this, you see that physics is ridiculously easy. I'm hoping that I can transfer this feeling after some time. But that comes, of course, with practice. That's that. Let's go to the next problem.